Hello, Michelle again, and today we are going to talk about botanical analysis and looking at charred remains. And that's kind of our last little section of major artifact categories in the prehistoric section. And then we'll start talking about historic archaeology and historic artifacts. But for today, we've got to get through botanical analysis, which is a really interesting topic. And so we talked in the faunal stuff about how organic material doesn't stick around very long in the archaeological record in this part of the world. It's just too hot and too wet, and just things break down really quickly if they're organic. But the exceptions to that are animal bones sometimes doesn't, and then charred remains often don't break down completely either. So if things get burned to the point that they keep most of their characteristics and features and they haven't just burned up to dust. I mean, you've seen a campfire. Sometimes you get pieces that burn, but they're not totally disintegrating, and other times you just have ash sitting in your fire pit. So when we get pieces that burn, and again, you can't see this really well, but you know what a piece of charred wood looks like. So we get pieces of charcoal like that you can kind of see some features and details on. And sometimes we find really tiny charred material. And that tiny material is sometimes fruit seeds from like persimmons or berries. Sometimes we find nutshell from different nut trees that grew around here and still grow around here. We sometimes find pieces of cane, which might have been used to build walls or might have been used for arrow shafts, things like that. Sometimes we find pieces of wood, and all of that is burned. And if we take those samples really carefully so that we don't mess up those preserved features and characteristics, then specialists called paleoethnobotanists or ethnobotanists or botanists sometimes, they can, usually using microscopes and magnifying features to look at these tiny features, they can look at these charred plant remains and they can identify the plants that they came from, often to species, which is really cool, but sometimes just to family. But even that gives us so much more information about the environment that was around and what people were eating in addition to animals. We talked a little bit about how animal bones can tell us kind of what the environment looked like based on what those animals needed, but the plant remains can tell us what plants were growing locally. And they can also tell us about domestication. So when humans domesticate a plant, and we know that Native American people were domesticating plants, there are genetic changes, and then those genetic changes show up as changes in features on pieces of the plant, like the seeds and other things that get charred. And so these specialists, these paleoethnobotanists, they can look at these plant materials and they can start to see domestication and when these plants were domesticated and at what sites they were domesticated. And that's super neat. And then they do all kinds of genetic studies as well on these plants. But I just think that the opportunities in plant remains are so interesting. And you can start to see, like I said, what kind of plants Native American people were domesticating and what ones they were foraging from plants that grew wild, and they weren't trying to domesticate them, but they knew where to go to get the different things that they wanted to use. And then, like I said, wood and cane, so building houses and things, sometimes those can be identified to particular species as well. And wood can sometimes then be aged using tree rings, so that's kind of cool. So lots and lots of different things you can do with plant remains. One of the biggest ones that I'm sure you've heard of is carbon dating or radiocarbon dating or AMS dating, we call it now. Excuse me. And you just need a tiny bit of charcoal and you send it off to a specialized lab. It's not something that we do in our lab at Parkin. You need a lot of scientific machinery and all that kind of stuff. But those specialized labs, they can date carbon. So I'm going to link you to a video that's really good, that gives a really good explanation of this in the comment section of this video. Just a really quick thing is, so carbon has multiple isotopes, and some of those isotopes break down more easily and more quickly. And those isotopes have different weights because of how the atoms are made up. And so in that specialized lab, they can weigh these atoms and then tell us how much of the different isotopes are in the sample, how many of each isotope, or the weight of each isotope. And then they can do a bunch of calculations and they can figure out then, based on those ratios, when that sample was alive and uptaking carbon from the atmosphere and from the soil in an area. And so that gives us a date. And by dating things, we can start to really center in more on when sites were occupied. When we talked about pottery decorations and stuff, we know kind of relatively when one pottery decoration style came in before another one or after a previous one. But with radiocarbon, which came about in like the 50s or 60s, we were able to start to say, okay, well, yeah, we know that this decoration came before this decoration, but how much before? And then we were starting to be able to say how much before, because radiocarbon dates sometimes can give you a 50-year time span. And in 50 years, that's not so long, really. Like me and my mom and my grandma were all alive together in the same 50 years, right? So that's not too big of a time span. We could talk about how cultures change and do things differently in that time span. Whereas if we only knew that it was somewhere in 500 years, well, 500 years, that's tons of generations of people. So that's harder to really talk about how people were doing things. But when you start to get those smaller distances in time, you can really start to pin things down. And especially when you get lots of radiocarbon dates, then there are all kinds of statistical analysis you can do with those multiple dates, and you can narrow it down even farther to really small amounts of time. And then you can start to say, like, well, this house at Parkin was occupied at this date with maybe, a 20-year time range, and then this house over here was occupied at this other date. And so you can start to see how people were moving within a site and what people were doing at different times. And it just gets to be really, really interesting stuff. And we could go on and on about this topic, but like I said, I'm going to link you to a really good video that tells you how radiocarbon analysis works. And they'll show you how they take a radiocarbon sample in that video as well. Because like I said, I have this whole tray of carbon artifacts here, but they just come from a general level. If we really wanted to do a good analysis of either the botanical remains or a carbon date, we would have taken this sample from a very specific context very carefully, and I wouldn't have it out on a tray and be touching it. But yeah, I think that kind of covers it generally. And next week we're going to have another guest post about more about botanical remains and how archaeologists are currently looking at those and learning more about domestication and early Native American gardens. So that's really exciting. I'm excited for next week, and I hope that this was interesting for you. And then in a couple of weeks, we'll start talking about historic artifacts, and I think that'll be really interesting too. So lots more to learn. We'll keep going with this, and I will talk to you soon.